Think of an atom as a strictly managed high-rise apartment building. Electrons are incoming tenants needing a place to stay, but they can't pick any room. Their placement is dictated by 3 fundamental laws of physics. Master these 3 rules, and you can accurately map how electrons are distributed around the nucleus. First is the Aufbau principle. Electrons are inherently lazy. Seeking the lowest energy state, they drop right into the lowest floor available. Higher floors are off limits until ground floors are fully occupied. The sequence moves strictly bottom to top. The word Aufbau translates to building up. Construct a solid foundation before adding higher energy levels. Now we zoom in to see how a single room operates. Physicist Wolfgang Pauli defined the exact occupancy limits for these spaces. A single orbital box holds a maximum of 2 electrons. If 2 try to enter with the exact same spin, the placement is rejected. To coexist, they must have opposite spins. The Pauli exclusion principle forces one up and the other down. This strict opposite spin requirement is the single mechanism that prevents orbital overcrowding. But what happens when electrons reach a floor with multiple identical rooms, like the p orbitals? This brings us to Friedrich Hund. You might assume the next 2 electrons will just pair up in the very first available room. That assumption is incorrect. Hund's rule states that electrons will completely occupy empty, equal energy orbitals one at a time before they ever begin to pair up. It operates exactly like taking a seat on a public bus. Passengers demand their own space, taking single seats until they run out of options and are forced to share. Let's test these rules by building nitrogen. It has 7 electrons. The first 4 fill 1s and 2s levels with opposite spin pairs, perfectly satisfying Aufbau and Pauli. 3 electrons remain. Pause here. How will those final 3 distribute across the 2 p boxes? Following single occupancy rules, they drop smoothly into separate boxes, each taking its own orbital with upward-facing spins. If we add an 8th electron to create oxygen, the dynamic changes. The new electron enters the first 2p box and immediately flips upside down. Because every equal energy orbital already has one tenant, incoming electrons must pair up. This move satisfies Hund's spacing requirement and Pauli's opposite spin rule at the exact same time. Let's review these visual behaviors. The first panel shows the Aufbau principle, filling energy from bottom to top. The second illustrates the Pauli exclusion principle, allowing a maximum of 2 opposite spin electrons per orbital. Finally, the third shows Hund's rule, enforcing single occupancy before buffering. By internalizing these 3 interdependent rules, you have the logical framework required to predict the standard electron configurations of the elements.